The lesson objective of this video: students use angle bisectors to find distance relationships. So we've already dealt with angle bisectors since the beginning of this year. Angle bisectors just cut an angle in half. So in my figure here, angle BAC is being bisected by ray AD. And so whenever we have an angle bisector, it's equidistant from the sides of the angles. Okay, so an angle bisector is equidistant from the sides of the angle. So what that means for this figure, if AD is a bisector, it's bisecting BAC, and I have to have that DB is perpendicular to AB and DC is perpendicular to AB, because the distance from a point to a line has to be perpendicular. Then I know that DB is going to equal DC. These two segments are congruent to each other. And the converse is also true. If I have DB perpendicular to AB and DC perpendicular to AC and DB equal to DC, then I know that AD bisects angle BAC. So we can use this property to solve some problems. In example 1 here, we're going to find the measure of angle CBE. So I can see in the figure that these two segments are congruent. I have right angles. So we've got that CE is equal to DE. CE is perpendicular to BC. And DE is perpendicular to BD. Because I have all of these things true, I know that angle CBE is congruent to angle DBE, because BE is an angle bisector. By the converse of the angle bisector theorem. And so if that's true, then I know the measure of angle CBE has to equal the other one, so it equals 31 degrees. This one's missing. These should be right angles here. Okay. All right. So for this figure, for what value of x does P lie on the bisector of angle J? Well, if it's going to lie on the bisector, it means it has to be equidistant. And so x plus 1 would have to equal 2x minus 5. And so then when you solve it, you just get that x equals 6. So just as we had concurrency for perpendicular bisectors, it turns out that angle bisectors are also concurrent. The point of concurrency for 3 angle bisectors of a triangle is equidistant from the sides. So point P here in the center is called the incenter. The incenter is the point of concurrency of the angle bisectors. And so when the angle is bisected, then we know there's an equal distance to the sides. So in this figure here, I can see that PF, PE, and PD are all going to be congruent to each other because the angles are bisected. And then yesterday, remember, we talked about if the side was bisected with the perpendicular bisector, then it's an equal distance to the angles. So if we bisect the angle, it's equidistant to the sides. If we bisect the side, it's equidistant to the angles. So if AP, BP, and CP are angle bisectors, then I know that PD equals PE and equals PF. And you'll notice that those are radii of the inscribed circle. And all the radii of a circle are always congruent. So we can use this information then to solve some problems. So in this diagram, point L is the point of concurrency of the angle bisectors, or the incenter, of triangle FHJ, and we are going to find LK. So first of all, let's look at what we're looking here. So we want to find LK, and I know that LK is going to equal LI and also equal LG, because those are all going to be radii of my inscribed circle. The distance is equal to the sides. So I notice that over on the side here, they've given me, this is 15, this side's 12, and so if I find LI here, I can find out how long LK is, because those are congruent to each other. And because this is a right triangle, I can use the Pythagorean theorem. So I know that Li squared plus 12 squared is going to have to equal 15 squared. And so we go ahead and square those. We get 144 and 225. And so if I subtract 144 from both sides, I get that Li squared is equal to 81. So that means that Li is equal to 9. And therefore, Lk is equal to 9. So I have a couple of problems here for you to try on your own. Why don't you go ahead and pause the video and find the answers for these two, and when you've done both of them, turn the video back on. Okay, so for the first one, we have that these are equidistant, and we've got right angles, therefore that means this is an angle bisector, so the two angles are congruent. 3x minus 5 equals 2x plus 5, and you solve it and you get x equals 10. For the second one, we have in the figure that these angles are congruent. That means it's an angle bisector. We have our right angles, so that means that the two segments would have to be congruent. And so 8x equals 7x plus 3, and so x equals 3. This concludes the video. Thank you for watching.